you very much for attending this webinar. My name is Jose Lamas. I'm product manager for GeneXus Server, and today I want to talk to you about GeneXus Server right now, what we are doing and what benefits you can obtain from using GeneXus Server. Okay. So in this webinar, I want to be talking about the UN that for a change. I do plan to talk about GeneXus Server, that is, to put it simply, the revision control tool for GeneXus projects. So I want to show you the many ways GeneXus Server helps you and why it's a must-have for anyone using GeneXus. When we develop software using traditional languages like Java, C#, C++, etc., we always use some revision tool like Substron, CVS, Microsoft Team Foundation Server, or any other. But in all these languages, we write code using plain text, and the source files are mostly text files. In contrast, when we develop with GeneXus, we don't have a collection of files, but we have what we know as a knowledge base, which is in fact maintained as a relational database. We modify this knowledge base using GeneXus, writing some code, rules and events, for example, but we also design forms, set properties, create objects, etc. None of these version control products will work for a knowledge base simply because a KB it's not a simple tree of files in the file system, which is what these version control systems expect and know how to handle. That's why we created a special product, GeneXus Server, which fully integrates with GeneXus and allows us to have all the benefits of using a revision control tool, but in this case, for GeneXus projects. Why is it so important to use a revision control? What are the actual benefits of using it? Well, most people associate GeneXus Server with team working, and it's right. GeneXus Server allows you to easily integrate the work of many developers in a single knowledge base, and it's the best way to allow teamwork for GeneXus projects. However, there are many other benefits from using GeneXus Server, even for single developers projects. In fact, some time ago, I wrote an article listing up to 7 reasons why you should use GeneXus Server even when you are the only developer in the project. I won't talk about all of them today because it would take too much time, but I want to show you the 3 most important of them. One of them is being able to keep track of all the changes you make, to have the history of your project. Also, using GeneXus Server, you have a way to manage different versions of the same KB. And finally, we'll see that using GeneXus Server allows us to automate many repetitive and time-consuming tasks, and in particular, to fully automate the builds. So, let's start with the first one, team development and see how we can use GeneXus Server for that. When we say team development, we are talking about how we can have a team of developers collaborating on a project and being able to innovate their work. In order to do that, with a revision control tool, be it GeneXus Server in the case of GeneXus projects or any other tool, we have what we call the repository, which is basically a central location in which a project is kept and maintained. This repository, in our case, is a KB located in the GeneXus server. The developers do not directly modify the repository. That is, they don't directly edit objects in the KB in GeneXus server. Instead, each developer obtains a working copy, works on it with GeneXus in the usual way, and then uses specific operations or commands to send changes to the repository or receive changes that other developers made to it. So, the work integration is based on just 4 basic operations, which are these. Send a given knowledge base to GeneXus server, or create a new local knowledge base from GeneXus server, commit some changes to the repository in GeneXus server, or in the other way, update your local working copy from GeneXus server. Let's see how this works. When we start a new project, or when we want to start using GeneXus server for it, we start by sending a KB to GeneXus server, that is, publishing its initial state. To do this, we use the send knowledge base to server command in the GeneXus menu. With this operation, a copy of the local KB is sent to the server, and that copy in the server becomes our repository for the project. The local KB is now a working copy of the repository. At any time, other developers may obtain their own working copy using the new knowledge base from GeneXus server menu. When they do that, they receive a copy of the current state of the KB in GeneXus server. GeneXus knows that the local KB published to GeneXus server and any other KB obtained using new KB from server are working copies, that they are connected to the KB repository in GeneXus server, and then it will enable operations that developers may use to interact with the repository. For instance, one of the developers, let's call him John, may do some work on his KB, say creating a new procedure and modifying some transaction structure. He then builds and executes from his working copy in the usual way, corrects some mistakes he found, tries again, etc., etc. When he thinks his changes are ready, he uses the commit changes operation to send his work to the repository. And then another developer, let's call her Mary, may use the update operation to receive in her working copy the changes that John committed to the server. Let's see this a little more detail. While John was modifying objects on his working copy, GeneXus was keeping track of which objects were changed. Icon overlays are used to indicate objects that are modified or inserted, since the last synchronization with the repository. Now, when he is ready to send changes to the repository, this is what John sees in GeneXus. First, there's a list of pending commits, that is, objects that were inserted, deleted, or modified on his working copy. He may double-click any of those to see the actual changes in each object. He can select which of those objects he wants to commit. He can write a description of the changes being committed, and then just press the commit button. For any of the other modified objects, he may just leave them for a later commit, or even use a command. Then, after John completed the commit, Mary will then use GeneXus to update her working copy. She may simply ask for a full update or ask for a preview. If she asks for a preview, she then obtains a list of all the objects that were modified on the server and that she may want to update. She can double-click to see the actual changes in each object too, and select which of them she wants to update now. Now, once she requests an update, it may happen that some object being updated was also locally modified by her. In these cases, GeneXus first tries an automatic merge. This automatic merge will work on most cases. For example, John may have changed the structure of a transaction, and Mary might have locally changed a rule on that same transaction. In that case, GeneXus knows how to merge both changes so that the transaction in Mary's KB receives the changes John made to the structure, but without losing her changes to the rules. Even if both changed the same part of an object, say they both changed something in some procedure code, as long as they changed different lines, GeneXus will most likely be able to merge the changes anyway. Of course, GeneXus always checks for the integrity of the merged results and reports any problem it finds. And even when it can't automatically merge some changes, for example, if both Mary and John changed the same line in the same procedure, it will anyway allow the update. In these cases, GeneXus just updates the procedure with the content in the server and clearly tells Mary that it couldn't automatically merge her changes and that she may manually resolve the conflict if needed. Since GeneXus also keeps a history of every local change to the objects, Mary has her change in the previous revision of the procedure and may easily compare it to the revision she received from the server and find a way to integrate her changes to it, or simply discard them if she wants so. So, that was a brief description of how GeneXus Server allows team development and how it works. But, as I said before, this is what most people identify as the main benefit of using GeneXus Server, but there are many more benefits, be it for teams or for single developers. One of them is that defining a repository and using working copies from which you send or receive changes also allows GeneXus Server to keep track of all the history of the project. For each object, GeneXus Server knows every change it was made to it, who changed it, when they changed it, what other objects were modified at the same time, etc., etc. Either from GeneXus Server Web Console or directly in GeneXus, anyone can see the commit history. Seeing the commit history of the project, you may inspect each commit and see which objects were modified, who modified it, etc. You may also compare the before and after states so as to identify what was actually changed in each object. For example, if you want to see what was changed to the customer transaction on this commit, you may use the show differences command, which will show you a detailed comparison. And in this case, we can clearly see that two attributes were removed from the transaction structure. Furthermore, if you wanted to undo changes in a commit, you may also use the revert command, which will undo those changes in your working copy, and you may, of course, later commit that reversion to the repository. Now, we're talking about history, but in software development projects, unlike in real life, there's not a single timeline, but usually we have multiple timelines. On software projects, we usually need to maintain multiple versions, and GeneXus Server also helps us on that. For example, many times we need to take a picture of the current state of the project. For example, when we are releasing a version of our product. That's what we call to freeze a version. For example, what we see in this image as 1.0.0 in yellow. That's the state of all the objects in the KB at the moment we release that version. We can even start a new development branch, what we see here as version 1.0.0 in blue, so that we can either make changes on the main line or on the line used for updates to the 1.0 version. Then, if we later release a 1.0.1 version, we can of course make a new freeze, eventually start a new development line from it, etc. And the same happens if we later release a new 1.1 version from the main line, and so on. All those frozen versions and development lines are maintained in the server. So, on the local side, when you create a working copy, you may select which versions and development lines you want on it. You then may select any of those versions on your working copy, so that you can make changes and commit or update from its respective version on GeneXus Server. So, GeneXus Server allows you to easily define and manage the different versions and timelines of each project. Let's go to the fourth benefit we are seeing today. That is build automation. Now that we have a centralized repository, that is, we have an official version of our project, and for each of its versions, then it's also possible to automate a process by which we update a working copy for any recent changes and build it for testing or deployment. That's what is known as continuous integration, a practice used on most professional development projects. And one of the most used tools for that is known as cruise control. So many years ago, we developed and published an add-in for cruise control so that it can recognize GeneXus Server as a source repository, just like it recognizes Git, SVN, or any of those I mentioned at the beginning. So with this add-in, you may use cruise control to define a process that monitors a given KB in GeneXus Server, updates a working copy on which nobody directly modifies objects. This working copy is only updated from the GeneXus Server. When cruise control finds commits since the last build, it updates the working copy and triggers a new build of it. You may define your project in cruise control to not only build the project but also publish the binaries, send a mail, trigger any notification, etc., etc. And that's one important benefit for any serious professional software project. So we talked about the main benefits you get by using a revision control, in this case GeneXus Server for GeneXus projects. These are, as I said, only the main benefits, but there are many more. But as it usually happens, the best way to get to fully understand these benefits and even find more is to actually try it by yourselves. And fortunately, easy for you to do. So my invitation now is for you to try very much. So that was the presentation I wanted to share with you. And now, if you have any questions, we may try to answer them. Questions, comments, feelings, complaints, anything you want. You're welcome, Nicolas. Angelo, hi. Really? Long time no see. Well, there's a question from Liv. Each installation of GeneXus Server is for one GeneXus version. However, in terms of licensing, if you have a license of GeneXus Server on the same server machine, you can install as many instances of GeneXus Server you want. They all share and use the same license. So the answer is yes and no. Angelo, can we have a recording of the meeting? Yes, we will make it available later. Thank you, Scott. I know you love it. Of course, you can send any questions as we mentioned. You can email them, and we are always happy to answer them. If we go to user controls, can one download the user controls from the server to the local machine? You have in version 15, you can upload the user controls. You cannot download them yet, but we are planning to add that functionality as soon as we can. Good. Any other question? It was a pleasure to talk to all. Thank you very much for attending the webinar, and you know how to reach us. Thank you very much. See you. Bye-bye.